Hello everyone, this is Mathematics and we are here with section 1.5 and 1.6 of algebraic expressions, Surds and rationalizing the denominator. Well, these two are separated in the book, but I have decided to put them and combine them together. So it will be much easier to solve the rationalizing the denominator questions by dealing with Surds, and this makes the video much more efficient, and you're gonna have the same regular period for video as you had for the previous sessions, but for 2 sections this time. So let's hop on to the topic. Guys, what is meant by a surd? If you have roots n, roots k, roots l, I don't know, any variable that you are gonna use. If you have roots n and n is a member, is an element of the set of integer numbers. So we know what integer numbers are. -2, -1, 0, 1, 2, and till the end. These are integer numbers. And if n is an integer number and n is not a complete square, if it is not 1, 4, let's say 9, 16, 25, if it is not these numbers and it is also an integer, then root n is called a surd. Guys, a surd and any multiple of it are irrational. What do I mean by irrational? Okay, we can write a rational number like this, where a and b are integers. Am I right? So a and b are integers, right? So the thing is, when a and b are integers and we can write it as a fraction, they are considered as rational numbers. 17 is a rational number. Why? Because I can write it as 17 over 1. 16.5 is a rational number because I can write it as 33 over 2. But root 2 is not a rational number. A surd is not a rational number. How? Let's go to the calculator. Root 2. Oh, the series of numbers doesn't end. So I have 1.41, 42, 13, 5, 6, 2, and it will continue. It doesn't end. So the thing that we know is that surds and any multiples of them are irrational, while integers or natural numbers, whole numbers, they are all rational and can be written in the form a plus a over b, where a and b are integers. Okay, all right. And guys, very important, you have two simple rules. If you have root a times root b, it will be equal to root ab, because it's just obeys the laws of indices. As you can remember, a to the power of 1 over 2 times b to the power of 1 over 2 is going to be ab to the power of 1 over 2, which will be root ab. So it's just the same. And root a over b can be written as root a over root b. And again, it's the laws of indices. How? If you have a over b to the power of 1 over 2, then you're gonna have a to the power of 1 over 2. You're gonna have a b minus 1 to the power of 1 over 2, which is gonna be a to the power of half times b to the power of minus 1 over 2. So by converting this to surd form, we will have root a over root b. So these are just coming from the laws of indices, and these are simply the things that you need to know for surds. And we're just gonna do some examples with each other. So I'm going to do exercise 1E, the last part, question 3. The question wants us to simplify root 75 minus root 12 as a root 3, where a is an integer to be found. Okay guys, whenever you come to these questions, you have to write these numbers in form of complete squares. How do I say that? Okay, we know that 75 is equal to 3 times 25, right? Okay, so I will write it as 3 times 25 minus, okay, and 12 can be written as 3 times 4. So I will just write 3 times 4. And guys, as for the laws of indices, I know that The first one can be written as root 25 times root 3 minus root 4 times root 3. And this is simply gonna be 5 root 3 minus 2 root 3. And it is very important, guys, to remember that if I have root x squared, the result is going to be modulus of x. What do I mean by modulus of x? If you don't know the definition of modulus of x, if x is less than 0, then modulus x is going to be minus x. If x is greater than or equal to 0, then modulus x is going to be x itself. What do I mean? Like if you have the modulus of minus 4, it is going to be 4 because it is less than 0. But if you have modulus of 5, it's going to be 5. So modulus is basically a function that turns every number, or let's say it is a function that only outputs positive numbers or 0 or positive numbers. If your number is negative, then it will be multiplied by minus 1. And if your number is a non-negative, which is 0 and positive numbers, you will have the number itself, and the modulus will not do anything. So this is just the definition of modulus. And you have to know that root x squared is going to be modulus of x. So the results of a root with, you see, even index, like here is 2. We do not write the index 2 for roots, and it is gonna be the positive root of it. So now we know that, and we're going for rationalizing the denominator. So guys, for rationalizing the denominator, the thing that you need to know is that when do we use rationalizing the denominator? It's whenever that you have a surd in the denominator. Guys, we must not have a surd in the denominator. It has to be simplified. So if you have a over root b, you have to multiply this by root b over root b. Any number divided by itself will be 1. So it will not have any effect on the actual result. So I'm just going to multiply a over root b by root b over root b, which is going to be a root b over root b times root b, which is a root b over b, right? Because this is going to be root b squared, and root b squared is simply b. Right, this is the first case. As for the second case, if you have a over b plus or minus root c, you are going to multiply this by b minus or plus root c over b minus or plus root c. Okay, how do we get to this result? By the difference of two squares. We knew that a squared minus b squared is simply equal to a minus b times a plus b, right? So, and guys, if I have b plus root c, I will multiply it by b minus root c. True? And this is going to be equal to b squared minus c. I don't have any surds anymore. But at the same time, the fraction is remaining the same. Its value does not change. So I'm just simply rationalizing the denominator. And if I have b minus root c, it's going to be multiplied by b plus root c. And it will be b squared minus c again. So by plus or minus and minus or plus, I mean that if the symbol here is positive, like it is plus, then here it should be negative. And if here it is minus, then here it is going to be plus, or here it is going to be plus. Doesn't matter. Okay, so this is it. And now let's solve a question together. Let's solve exercise 1F, question 4, which wants us to simplify 3 minus 2 root 5 over root 5 minus 1. And we should give our answer in the form p plus q root 5. And p and q are rational numbers. So even if they are fractions, it doesn't matter. So, guys, as I told you, 3 minus 2 root 5 over root 5 minus 1. We look at the denominator. Is it a surd? It contains a surd. It is root 5. So I have to multiply this surd by its conjugate. Guys, you saw that I wrote this as if it is b minus root c, then it is going to be multiplied by b plus root c. b plus root c is the conjugate of b minus root c. And b minus root c is the conjugate of b plus root c. So if the sign in the middle of the surd and the rational number are changed, then they are said to be each other's conjugate. So the conjugate of root 5 minus 1 is going to be root 5 plus 1. Root 5 plus 1. And I'm going to write 3 minus 2 root 5 times root 5 plus 1 over root 5 squared minus 1 squared. Okay, this one is going to be 3 root 5 plus 3. Okay, let me go to the next slide. So 3 root 5 plus 3 minus 2 root 5 root 5 minus 2 root 5 over 5 minus 1. So I just need to simplify this one, right? 3 root 5, and here I have minus 2 root 5, so it will be root 5. And root 5 is simply 5. Minus 2 times 5, minus 10. So I have plus 3 minus 10 over 4, which is going to be minus 7 plus root 5 over 4. And our answer will be minus 7 over 4 plus root 5, or 1 over 4 times root 5. So we have our answer in the form p plus q root 5. So our p is going to be minus 7 over 4, and our q is going to be 1 over 4. And here we go, Surds and rationalizing the denominator is finished. And in total, chapter 1 is finished. Algebraic expressions are finished, and from the next session, we are going to move to quadratics. See you all in the next session.